Hypothalamus Artificial Intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents its products and experiences in financial chain optimization. This video is confidential and may not circulate outside the receiving company without HI's authorization. Artificial hypothalamus. The power of today's technology is not in the mathematical calculations that it allows to perform, it is in the mathematical calculations that we can imagine that we can perform. Against the Gods, the remarkable story of risk. The measure of our ignorance. This type of modeling is known in the financial sector as enterprise risk management, ERM, and assets and liabilities management, ALM. According to Peter Bernstein, in his book, Against the Gods, The Remarkable Story of Risk. The revolutionary idea that defines the boundary between modern times and the past is the mastery of risk, the notion that the future is more than a whim of the gods and that men and women are not passive before nature. The essence of risk management lies in maximizing the areas where we have some control over the outcome while minimizing the areas where we have absolutely no control over the outcome, and the linkage between effect and cause is hidden from us. The table presents the models developed by HI for the mathematical optimization of the financial sector. Corporate financial risk control. The Basel Accords are international standards that provide a common measure for quantifying banking risks and comparing them. This is very important in the case of internationally active banks, to avoid regulatory asymmetries. The international financial crisis of 2007 to 2009 led the Basel Committee on Banking Supervision to launch the Basel III Agreement in 2010, the essence of which is the macroprudential approach to supervision. Until then, supervision was basically focused on the entities considered individually. From then on, the evolution of the financial sector as a whole is also analyzed, from a systemic point of view. Hence the need to control financial risk, at the level of the entities, and their conglomerates. Enterprise risk management. Challenge: to develop mathematical models for the financial risk management business of transport insurance. Solution: development a theoretical framework with corresponding technological implementation through an optimization model to support a system of measurement and control risks in accordance with standards established by the Colombian Financial Superintendents for the Insurance Industry. Implementation of a non-anticipative stochastic optimization following the ALM, Asset Liabilities Management, methodologies. Result: implement the ALM optimization model in a server of the client. This type of modeling is aimed at incorporating production and financial modeling into a single model. Research and development project. Challenge: to implement an optimization model that integrate the production with the financial modeling to permit the enterprises to implement optimization models for the integrated business planning, IBP, process to improve the decision-making process. Solution: design and implementation of an optimization model that connect financial, ALM, with supply chain planning, SANDOP, models allowing to optimize cash flow and treasury management, working capital, fiscal management, dividends, capital repatriation, payment/prepayment of liabilities, capital and equity structure, and transfer prices. Based on stochastic programming framework, SANDOP ALM may include corporate financial risk analysis. Result: a prototype SANDOP/ALM model was developed by a HI professional, as part of his postgraduate thesis in UPC, Universitat Politècnica Catalunya. Additional to the production/distribution variables, it produces financial statements, I, losses and gains, 2, cash flow, and 3, balance of assets and liabilities. The model was applied to optimize transfer prices in a realistic beer global supply chain. Extended ALM modeling may include investments in alternative assets and liabilities, payment of dividends, capital repatriations, capital flow, and multiple currencies. In healthy logic, this model must be the coordinator of the holistic investment process, since it is the financial vice presidencies of the organizations responsible for endorsing investments in production assets. Supply chain design and financial risk management. Research and development project. Challenge: To implement an optimization model that integrate the production with the financial modeling to permit the enterprises to implement optimization models for the design of global supply chains. Solution: design and implementation of an optimization model that connect financial, ALM, with design supply chain, SCD. The design considers that conventionally, supply chains are designed to function optimally under normal conditions, without considering the resilience of the chain to extreme events, natural disasters, flow interruptions for abnormal reasons, strong changes in prices and availability, that represent a major risk factor that entails, among many, increase in operating costs, penalties or costs for not serving the market. Based on principles of stochastic and robust programming, the goal is to design a supply chain that operates very well under normal conditions and well when extreme events occur. Result: implementation of SCD-ALM model applied to a realistic beverage supply chain in LATAM. Including risk management constraints. The high methodology for mathematical modeling of the supply chain network design involves at least 3 types of models. Investment coordinates the logic of investments in the present and in the near future. Operations estimates operating costs and operating policies, which are derived from investments, and financial coordinates the cost of investments and operations with financial flows to ensure their viability and financial convenience. Additionally, it must control the financial risks due to investments. The first model will be called LogFin. It is oriented to define the investments to be made in infrastructure necessary for production. It corresponds to a dynamic model that defines, for each period of the planning horizon, the investments to be made, and the network for short-term operation. As input parameters, it should consider the costs of investment, rate of return on capital, the costs of loans, payment period, and other financial considerations. Model constraints are related to investment logistics and financial risks. The main results of the model are NPV, net present value, of the investments, VAR, value at risk, cash flow, and network design for the first periods. The second model will be called SANDOP. It is aimed at simulating industrial operations for each possible network proposed by the investment model, LogFin. As input parameters, it should consider, at least, the forecast of demand of final products, raw material supply, operational costs, and sell prices. The model can be extended to consider other aspects such as technological innovation that affects the productivity of processes, new technologies, which may affect market prices, and others that are considered convenient. In general, all input parameters are uncertain, and it is appropriate to consider that this makes a stochastic programming model based on scenarios. This characteristic makes the LogFin model a coordinator of the evaluation of the scenarios to be considered in SANDOP. It corresponds to a dynamic model that defines, for each period of the planning horizon, the industrial operations, and the storages of materials. In certain cases, it may not be necessary to consider product storage, because it may have little impact on investment costs, and additionally, it may be considered that its offer is always provided by the market with stable prices. This is not the case for oil storage, where the market prices and the supply of oil and gas is uncertain with high volatility. The constraints of the model are related to the industrial production process. Normally, there are several alternatives to simulate this process. At one extreme, we may formulate a very simple model, perhaps a few aggregate equations, that synthesize the process. At the other extreme, we may formulate a detailed model that simulates the processes with great certainty. The decision is of the modeler. What is true is that the available computer technology, computers plus solvers, allows very advanced models in this aspect. Therefore, the level of detail will grow exponentially in the next years. The main result of the model is the operational simulation for each period for each scenario. Data that are necessary to evaluate the future cost function that generate the decisions of the present. The third model will be called ALM. Its objective is to simulate the assets and liabilities management, ALM, considering the results provided by LogFin and SANDOP models. ALM is a modeling consolidated methodology that focuses on the financial modeling of companies. Its growth is generated at the end of the past century, in the financial sector, as a result of the Basel Accords. The minimum ALM modeling should be oriented to evaluate the NPV, for a pre-established ROI, return of investments. It will provide the financial statements, balance sheet of assets, liabilities and equity, income statement, profit and loss, after tax, royalties, and other contributions, and cash flow. Consulting project, Global Supply Chain Design. Challenge: in 2024, a multi-Latin company hired HI to redesign its global supply chain, in order to determine how best to serve the Latin American and North American markets. Modeling involves the coordination of an international network of raw material plants and end product plants. Solution: applying the new HI methodology for the resilient design of global supply chains, including financial risk management. The model is called GSCD. Result: project in progress. The result will be the implementation and use of the GSCD to determine the best global supply chain for the multi-Latin enterprise. Optimization of financial logistics operations. Optimization of the operations required for the functioning of the financial sector. Efficiency analysis of non-homogeneous production units. Challenge: to implement a mathematical non-parametric methodology to support relative efficiency analysis of non-homogeneous production units. Solution: implementation of an optimization model to evaluate the relative productivity of process units in several industries based on DEA, data envelopment analysis, and its variations, that allows to establish efficient Pareto curves for non-homogeneous production units, bank branches, hospitals, market agents, employees, and others that produce different types of outputs and use multiple types of inputs. Result: implementation of the DEA model in a web server to be used as OAS, optimization as a service, to supply services of relative efficiency analysis. The literature reports cases of identification of annual overspends of $6 million for reasons of relative inefficiency in an analysis of 33 branches of the Citibank. Bank network optimization. Challenge: to design and implement a model aimed at establishing the optimal network of fixed assets, facilities, of banks, offices and ATMs. Solution: implementation of a model aimed at establishing the optimal network of fixed assets of banks. Result: implementation of the optimization model in a web server, to be used as OAS, optimization as a service. Its use is important to make the location of new facilities, and relocation or close of actual facilities. The second decision is typical of the processes of buying or joining banks, that already have their own infrastructure, and by joining the two banking networks can present oversizing of the new banking network. Mobile human resources optimization. The solution developed by HI is composed of 5 specialized mathematical models that support the bank in making optimal decisions for strategy, tactics and operation. One model is oriented to the knowledge of the stochastic process that governs the behavior of demand, and 4 models to the planning of the supply chain of cash and another of services. These models are: DEM, probabilistic characterization of the behavior of the demand for services that bank branches must serve. LAY, optimal design of the capacities of a branch, or of a set of branches, according to the demand to be met. PTA, optimization of human resources hiring for the medium and or long term. POD, scheduling of staff assignments, roles, to branches to meet short-term demand, and APS, assignment of persons to attend to the planning carried out in the previous model. Human resources planning and scheduling. Challenge: to solve the problem of human resource allocation considering a geospatial dynamic demand of human resources. Solution: design and implementation of an optimization model for human resource allocation considering a geospatial dynamic demand in which services changes throughout the days and times of the day over the space. The solution of the model: minimize allocation costs, increase the level of customer service, and generate employee comfort. The model generates the timetables for each human resource. Result: implementation of the model in a web server to be used as OAS, optimization as a service, and use the model in proofs of concept. Vehicles routing and cash transport. Challenge: to implement an informatic tools to optimize its collection and distribution operations of cash and securities. Solution: design and implementation of a set of mathematical models to define routes of client services, assign vehicles to routes, and assign crews to vehicles. Result: deliver the models to the client who implemented the models in its information technologies system. Cash transport vehicles routing models interconnectivity. The implemented solution involves the coordination of multiple models, each with a specific function, since it is not practical, nor viable, to think in a single model that does everything. Under the concepts of HI, in practice it is in an artificial brain. Like Herbert Simon, hypothalamus artificial intelligence believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.